All right, in this video, we're going to be talking about nested types. In C#, on either class or structure definitions, you can actually stick additional types within that type definition. Not only that, you can stick additional types within those type definitions and so on.
Well,
So,
you're saying that you can actually stick type definitions inside of type definitions.
yes.
Okay.
So let's go ahead and fire up a project and see what those look like. So basically, if I have a class called person, and he can have a nested type, and what I mean by nested type is any type that you can declare normally. So he can have a nested interface for whatever reason. I don't know why you'd want that. You can have a nested class. He can have a nested enumeration, and he can have a nested delegate, and so on, and nested structure. So the idea is that you can actually stick classes inside of classes in a very simplified way of saying it. These types also, their accessibility is important. For example, all three of these types are private, despite the fact that both interface and enum by default have a public accessibility. When they're nested, they don't, and everything in here is private. So as far as what nested types are, that's about it. But there are some reasons to actually use nested types in your programs. One of the reasons I come across is when I kind of have a very complicated class that performs a lot of different operations that I don't mean a lot of different operations as in has more responsibilities than it should. What I mean is that the kinds of computations that it does requires me to separate my methods into multiple types. I will make private nested classes in order to facilitate that don't end up cluttering the global namespace. Another reason you might use a nested type is an interesting facet of a nested type is it can access the private variables of its enclosing type. Now, I don't want to leave without an example. So I can go ahead and show something, somewhat of a pattern that is useful on occasion. And the example I'm going to put up is a bit contrived, but it'll hopefully serve to demonstrate one of the use cases of a nested type. So let's go ahead and say iPrinter with the method called void print. And let's say we have a public iPrinter getPrinter method. And let's say we want to actually return out something that we want private and internal to person. Let's say the iPrinter that we want to return from here needs access to the private members of the person class. What we could do is we could create a private nested class called personPrinter that implements this public interface. Let's go ahead and implement as member. And then finally, let's go ahead and do a private string name, private read-only string name, sorry, and then go ahead and give this person a constructor that takes in a name argument and assigns it to his local variable. And let's go ahead and stick this guy under our private class definition. So when this person printer is instantiated, he's going to take in a person as an argument. And when he's printed, he's going to go ahead and do console.writeLine person.name. And when we say get printer, we can just return new person printer and pass in this. So like I said, this is a slightly contrived example, but hopefully it shows what the kind of stuff you can do with nested types. So let's go ahead and just use this real fast, just for and we see that we get the expected output. So yes, those are nested types. Again, the biggest use case that I see for them are when you want to implement an interface, but have that interface that you're implementing have the class that implements the interface that you're implementing has access to private members of the class that is returning that interface. In this case, you could follow this pattern. Or in cases where you might need to define a little bit of a data structure for the kind of data that you're storing, in which case private classes are a good candidate for that. As far as using private enumerations or private interfaces, those are less desirable. And as far as public nested types, those are also less desirable. The reason is if you have a public type, you expect to be able to instantiate it. But instantiating a nested type is cumbersome because you have to additionally qualify the type with the type of the enclosing type name.
Okay.
So, yeah.
Was that pretty much everything that you wanted to cover here?
Yep.
All right, fantastic. Well, with that, we'll conclude this video. Thanks a lot, everyone.